Hey, welcome everybody to another live session here. My name is Brian McLogan, and what I'm going to do for you in this session is work on a quiz that I recently gave my students last week. And this quiz is from pre-calculus. It is in analytic trigonometry. And basically what we covered in this one was simplifying expressions, verifying identities, finding the solutions to a trigonometric equation, and then we did some kind of free response and stuff like that. So just to kind of give you a little update as far as where we are in the class, we have, let's see, we're covering up sum and difference as well as half angles, but that's all we really cover in the analytic trigonometry section. So we have sum and difference, half angles, and then we'll be doing another quiz, so I'll be going live again with that quiz. And then we'll be wrapped up, and then we're going to get into the applications of trigonometry, such as, law of sines, law of cosines, and we'll get into vectors and more word problems and parametric and polar equations. So that will be coming up after this unit for those of you that are kind of following a similar structure. And if you're not following a similar structure, if you're in a different class or, your class is kind of done a different way, just a reminder that I believe I have the... Oh, shoot. Why is that giving me a bad... I'm getting a bad live stream, but I'm not sure. I don't know. Let me know if anything's it's kind of coming fuzzy because I'm not getting a good stream health. So hopefully everything's going all right. But if there's any issues, let me know in the chat because I am monitoring that for you guys. So anyways, but if you guys are looking for some of my previous live streams where I've covered, other topics this year, as far as my homeworks as well as my quizzes as well, those are in the description below as well. So you can just go ahead and access those old live streams. And then obviously if you kind of like these documents and you would like to kind of do them on your own or kind of check my answers with yours, obviously I have access as well to the YouTube membership is one of the things that I provide to my students or at least the people that are in the YouTube membership to kind of like check that out. And I'm also looking into doing some private live streams with that as well. So either way, those are just some other things that we're doing. I still have some quizzes I got to grade, so I kind of like to get right into this, but I will say hi to a couple of you guys that you're starting in. So Janice, Stellar, let's see. Not my eyes, man. I hope I'm not that old. I think that's Benny. I think that's a double. I don't know. It's just maybe I can no, I can't zoom in. Bernie, David, Blue CSU, Andrea, Gaming Zone, SLV Studio. Good to see you guys. Harmon, thank you for coming into my chat. It's very good to see you guys. Basically, again, what I'll do is I'm just going to kind of run through the stream here real quick. I'm sorry, not run through the stream. I'll run through these free response questions on this quiz, kind of show you guys my step, explain things. Then I'll kind of take a quick little break, see if there's any questions that you guys have. And then what I'll do is if there's any questions or any other work outside of this quiz, guys, I'm going to handle them outside after the quiz. So just to let you guys know. And Ballhairs, yes, this will be live with session. This live session will be up on my channel. So if you got to go, if it's not a good time for you, then just go ahead and you can always check the replay. No problem. And hey, Crystal from New York. Good to see you. And your question is, all right, well, any questions I'll be able to get to after the live stream, depending on how long this takes me. So let's go ahead and get into this first problem. It says simplify the expression to one single trigonometric function or number. So basically what we do here is you guys can see that we have three trigonometric functions, and they all, we could all use trigonometric identities to kind of simplify these or to rewrite them. So the sine of pi halves minus theta, that is our cofunction identity, which is going to be cosine of theta. And the way that I kind of memorize that is, again, thinking of the transformations of the graph. Cosine and sine are cofunctions of one another because you can apply certain given transformations to the sine graph. It's only going to look like cosine. And that is true for cosine to sine, and as well as tangent and cotangent and cosecant and secant. For these next ones, you're taking the function of a negative angle, which is going to be our even and odd identities. And everything that I'm saying, the reason why I'm saying these identities, because I'm not going to show them, because that's something we've done in class multiple times. And if obviously it's either they're in your own notes or a quick little Google search and you can see even and odd identities. And that will pull up the identities that I am referring to, or cofunction identities. Anyways, the sine of negative theta can be rewritten as a negative sine of theta. Now, I didn't like a lot of the notation that some of my students were using on this one. So they were just kind of putting a negative, and I thought that kind of got a little bit confusing because it kind of looked like they were subtracting them. And I don't recall anybody making any major mistake there, but it could. You know, if you come back to it, you didn't finish it, and you come back to it and want to finish the problem. If you don't have the correct parentheses there, and again, you don't really need to put parentheses around the theta. I'm just doing it in this case. But either way, that could be a mistake. All right, so just remember that the secant is even, so therefore the secant of a negative angle is the same as the secant of theta. And now I could rearrange these, but to save ourselves some time, hopefully you guys can recognize, hopefully you guys can recognize that the cosine of theta and secant of theta are reciprocals of one another. So without rewriting them in terms of cosine, you can see since they're reciprocals, they're going to multiply to give me negative, or multiply to give me 1. So therefore, I'm just left with negative sine of theta. I don't know why my pen sounds like it's not being able to write things in. So, Taylor, just sorry, real quick. Taylor says, "Are you allowed to ask questions?" Yes, Taylor. If you're allowed to ask questions, please do ask questions. All I tell people is I am going to really focus on the stream. I will check in though. So if there was any questions that you have while I'm talking about this, I will answer those questions at the mid break, and then I'll go back to those. If you have any personal questions on problems you would like me to solve, I will address those after the live stream, or after I am finished with my quiz. But yeah, feel free to type the questions. I'll try to go up there and check as many questions as I can. All right, so and SLVSE or piecewise function, just go ahead and just type in what you'd like me to talk about piecewise, and I'll do that at the end of my quiz. So verify the expression. Now this one was, a lot of students had trouble with this one, and that's like, what the heck are you trying to do, Siri? No. Okay. A lot of students had trouble with this one, and that's what verifying does. And I told students to try it. Like many times, like it just takes a lot of practice with this one. Immediately, we did do a lot of problems that had the rationalizing. So since I see 1 plus cosine, I do recognize that I could immediately multiply by the conjugate. So I think the easiest way to do this problem was to work on the right side first. Okay, by working on this right side now, I now obtain, sine of x times 1 minus cosine of x, and then this gets to be multiplied as the difference of two squares, so that becomes 1 minus cosine squared, which is the same thing as sine squared of x, right? 1 minus cosine squared of x is equal to sine squared of x, and the reason is that's a Pythagorean identity. Now, these can divide out, and then you can divide the sine into both of those terms. So therefore, you're now left with 1 over sine of x minus cosine of x over sine of x. Now, cosine of x over sine of x is equal to cotangent, and 1 over tangent is equal to cotangent. So that's another thing. You can see that it's obviously equal to each other. You could rewrite this if you wanted to, or you could keep on going. I kind of accepted it at this point, but obviously you could continue to write this down as 1 over tangent of x. And that would be your kind of foolproof. Now, let's say you wanted to work on the left side, because a lot of identities that we do work on the left side. And I saw a lot of students trying to add these with the common denominator of tangent, which is fine. I didn't work away that way, and to kind of save myself time, I'm just going to kind of do the idea that I looked at with this. And the way that I first looked at this was, whenever I got stuck, I always told students to convert things as sines and cosines. So if we were to rewrite this in terms of sines and cosines, you would have this as 1 over sine of x minus 1 over sine of x over cosine of x. Well, again, guys, we can rewrite this as a reciprocal. So we can rewrite this as 1 over sine of x Actually, you know what? If you rewrite that as the reciprocal, I'm just going to do that point to save myself some time. Obviously, this is 1 over cotangent as well. So cotangent is cosine of x over sine of x. So therefore, you have 1 minus cosine of x over sine of x. Okay. Now, again, we're trying to get it to look like this. So again, do the same thing. Look into rationalizing. So add 1 plus cosine of x times 1 plus cosine of x. And now, when you rationalize it on this side, over here, you're going to get 1 minus cosine squared, which we already know is sine squared. And that's going to be over 1 plus cosine of x times sine of x. And now, again, we have these sine of x's that divide out. And you guys can see that we are now with the other side. Sine of x equals 1 us cosine of x. Okay? So, either way, you could have worked on the left side, you could have worked on the right side. I'll just kind of draw a line. Either way would have worked. And again, guys, this is not the only 2 ways you could have solved these. I'm not claiming this is the fastest, the easiest, or whatever else, because I always get those comments on my channel, you should have done it this way or whatever else. These are just 2 ways that I looked at the problem. And again, so if you looked at the problem differently, I did have students that solved it differently, which I don't remember, so I'm not going to go through all the different examples that I saw. But I think that this at least gives you a good idea of 2 ways to verify this identity. Verify, and I should have written that wrong. This should be identity. Okay, so now let's go into solving equations. So solving equations, basically, again, guys, solving equations is just like solving equations in Algebra 1. The exact same thing. Think about it like this. Forget about the cosine of x. Just think about 2x squared. If you were to solve this, you could, we had 2x is equal to 1, and then you divide, x squared, divide by 2. And x squared, you could factor it actually, difference 2 squares, or you can get 1/2. Now again, a lot of students got to this point, but then I was amazed by how many students, 1, forgot to take the square root of both sides, and then 2, I'm not going to go through the work because this is again Algebra 2, but how many students forgot the plus or minus, as well as did not simplify to x equals plus or minus square root of 2 over 2. It happened a lot. So when we're doing this problem, it's the same steps. It's the same thing as, algebra, like in Algebra 1. You add 1, you got to isolate the cosine function. So you divide by 2, and then we have cosine squared of x equals 1/2. So now you take the square root to get rid of the squared. And for those of you, all right, fine, I'll break down. I'll just show you. So this equals square root, let's write the plus or minus so I don't forget. So just remember the rules of radicals. Plus or minus 1/2 can be rewritten as the square root of 1 over the square root of 2, which is 1 over the square root of 2. And then we rationalize the radical, And this is not the first time that I'm showing this in my class. This is like multiple times that I have done this in my class. So that's why I might be a little short with you guys, which I don't mean. Some of you guys might not have done this, but we've covered this a lot. But there's a lot of mistakes on this problem, and I was actually kind of surprised. So I don't know, maybe we'll have to kind of see, where when they look at it, where that was, because we did do problems like this, in before the quiz. All right, so now basically we got to figure out, this is finding all the solutions. So we look at the unit circle and we figure out, well, when are the angles going to equal plus or minus square root of 2 over 2? Well, hopefully from the unit circle, that's going to be at the angles with the reference angle of pi over 4. So these all have a reference angle of pi over 4. And what's even more important about this is you can see that they actually are equidistant from each other as well. Right? So now we just got to think, well, how far are they actually away from each other? Well, all the way around circle is 2 pi, right? It looks like half of a circle is pi, and it looks like we're about half of that. So it's pi half. So the way that we can write this in simplified form, we could write every single answer, right, on the unit circle and then do plus 2 pi n. because if you take an angle and then you add 2 pi to it, you're always going to get another answer. And you can, obviously, there's infinite many solutions. So you could always add and subtract 2 pi. And the way that we infinitely write 2 pi, adding, subtracting 2 pi would be 2 pi n, where n is an integer. But an easier, the simplified way to write this would just be x equals the smallest positive angle, which is pi over 4, and then plus pi halves, which will take me to my next answer, n. And that would be our simplified answer. All right, for the next example, this was a difficult one. You know, I really was kind of trying to test some students with this. We did kind of cover this, and we did cover it in class. But, you know, there's kind of 2 things that I really wanted to see with students. One, you know, could they recognize the zero product property, which a lot of them did not. And again, I think that's kind of the most important thing. We're looking for the solutions, guys. And, you know, don't go too far back into math. Like when we had x plus 1 times x plus 2 equals 0, you know, students immediately got confused. They're like, oh, you distribute. No, we're not distributing, you know, anything. We have a product equal to 0, so we can set each of those factors, that's what they are, factors, equal to 0. And this is the exact same case. We have a product equal to 0. So the first thing I was looking for my students to do was to set each factor equal to 0 so they could solve. Okay, so I think that was like that's the essential, you know, portion here of being able to understand this problem. The next one is not so much as important, but I think it was, actually, you know, I'm just going to kind of continue it. So I'm not going to use the substitution. I did that in class, but I'm not going to go through in there because it'll just, I don't want to confuse any additional confusion at this stage in the game. So just like we did in this last example, let's isolate the sine function. Now, again, we can't undo anything inside the radical. Now, I will talk about that. So this happens all the time. Like square root of, you know, x over 2 equals 5. If I said, like, solve this, we can't, like, multiply by 2 on both sides and because it's under the radical, right? So what we have to do is we have to square both sides first. This is the same thing. We can't do anything with this angle inside of this, with this 2 inside of the trig function until we've undone the trigonometric function, just like we'd have to undo the square root function. So let's first isolate each trigonometric function. This one's already isolated, so that's awesome. Let's go ahead and isolate this one. So add 1. So this is actually the same inverse operations. I don't want to write in red, though, or in purple. So we have to sine. Actually, you know what? I think you guys know your inverse. I'll just write them in there. Why not? I got time. L2 equals 1, and then we'll divide by 2. I'll just show all my work. So we have sine of alpha divided by 2 equals 1/2. Now, the one way you could look at this is just forget about alpha, or forget about alpha divided by 2, and just think about an angle. When is sine equal to, you know, 1/2? Let's draw a unit circle over here. So when is the sine coordinate equal to positive 1/2? Well, that's going to be these 2 angles, here and here. Now, it's important when we're trying to find all the angles between 0 and 2 pi, and not all the solutions, we want to actually first start with finding all the solutions. So if I need to find all the solutions, these are not equidistant between each other, right? So we can't do what we did in this last example. So what I'm going to do is I'm just going to take these 2 angles and just add 2 pi into them. So I'll take alpha divided by 2 is equal to pi over 6. And then alpha divided by, and that's plus 2 pi n. And then I have alpha divided by 2 equals 5 pi over 6 plus 2 pi n. Okay, now to solve for alpha, I need to multiply by 2 on both sides. And I need to do that on both equations. So what that looks like now is alpha equals pi over 3 plus 4 pi n. And alpha equals 5 pi over 3 plus 4 pi n. just make sure you multiply that, distribute the 2's, right? So you got to make sure you distribute those 2's. Okay, and sorry about my penmanship a little being rough there. Now let's go and figure out the next one. When is tangent of some angle to alpha equal to 0? Well, remember tangent is y over x, so that's going to be at 0 and at pi. So now this one, these are equidistant from each other, right? You can see they're pi away from each other. So the way I'd write this one is 2 alpha equals pi n. Now you could do, again, since they're pi away from each other, right, you could do 0 plus pi n, but that doesn't really make any sense. Just do pi n. So now when I go ahead and solve for my alpha in this case, I get alpha equals pi halves n. So again, we're trying to find all the angles that between 0 and 2 pi, right? So let's go ahead and write the solutions down here. Okay. Now, did I do these in order? I do not think I did. So we know we have these two solutions, right? Let's just pick values for n, and that's what I kind of did. So we wanted you to have these 3 equations, right? If you had these 3 equations, that was really good. Now, basically, what we want to do is, well, how many of these solutions can we fit between 0 and 2 pi? So let's start when n is, 0. When n is 0, we have pi over 3. We have 5 pi over 3. I'm not doing these in order. And then this would be 0, right? Obviously, when n is -1, you have, like, the lowest value is 0, so that wouldn't work. Now let's plug in n as 1. Well, when n is 1, these two angles are going to be larger than 2 pi, right? Because you're adding 4 pi to both sides. So now we're just going to focus here. So when n is 1, we have pi halves. When n is 2, we have pi. When n is 3, we have 3 pi halves. And when n is 4, we have 2 pi, but that is not included. So therefore, we're just going to end at 3 pi halves. So there you go, ladies and gentlemen. That is how you solve the find the equation using the 0 product and the sum and difference. I'm just going to take a quick little break, zoom out here a little bit. If any of you guys want to go ahead and take a break yourself and maybe go ahead and try to do some of these problems that I provided. I will just go and check in, see if there's any questions or anything else that I did on my last one. I go to stay in high school, help me a lot in my homework. So yes, SLV Studio, let me know what kind of questions you have on piecewise. I'll be happy to help them. Are vertex form and quadratic form the same thing? I'm not sure what quadratic form is, Lingard. Usually, refer to standard form. But obviously if you're, so I'm not really familiar with quadratic form, or at least it's been a while since I was teaching the quadratic, so I'm not sure what they would have been referring to on that. Jonathan, I'm very helpfully to help you out, Jonathan Calderon, with your homework. I like this new form of teaching by streaming. I do like it too. I think it's very helpful, just for anybody, to be able to answer questions and stuff like this. What's the equation for time traveling? I have no idea. Well, very happily for Jonathan Calderon and your crew to be able to help you guys out. So hopefully I'd like to expand the live stream a little bit more. I mean, obviously this year is kind of like my entry level, first year I'm doing all my pre-calculus class, and that, because since I'm only teaching this, it's been helpful for me to be able to do this. But I would like to expand it into some more classes, and kind of continue that. But it's been nice to kind of create all this material, for pre-calculus, so therefore I can kind of continue offering it to people that are taking pre-calculus later. I'm not sure how my live streams are going to go next year, because it's going to be based on what I'm teaching. But either way, I think I'll still probably plan on going live for a while. And awesome. So evil. Thank you, Chris. Justin says, "Can you see this?" Yes, Justin, I can see this. How can I figure out how many items must be produced? Taylor, I am not sure on your question. Those are a little bit too bigger numbers. I don't have a calculator, and my recommendation would be looking into where n is the number of items produced per day. How would I figure out how many items must be produced? I'm not really per day to have a maximum profit. Well, you will need to. my recommendation, I would just type that into Desmos and see where the vertex is, which would be the maximum. But I believe you would need another equation because I'm not sure what I guess that's your profit equation. So yeah, so I would just type that into a graphing calculator and then find the maximum points. And then obviously your N represents the number of units. What is your opinion on AP calculus? Well, I'll get to those questions later. So I'll come back to that. Anybody have any questions on this? Please do some factoring. Youngest, if you can just let me know what kind of factoring you want me to, then I'll go ahead and get to that. So just let me know what kind of factoring problem you want me to do, and I'll do some. Can you help me with an example how to find the y prime with a rational equation? No, I can't. I could, but my brain is all focused right now, and I took this year off with my calculus, so I'm not going to be 100% confident that I'm going to be like jump right back into it on a live stream. I do help out a couple students with their calculus, and it takes there's like a little 5-minute, 10-minute lag that it just takes my brain to remember, to kind of go back through, get into that mode again of calculus, and that's not something that I quickly just jump right back into, even though that's what people think. Oh, you're good at math. You can just do all this. I'm no, I'm not really like that kind at all. It takes me a little bit to bring things to remember. So yeah, I probably the live stream wouldn't be the best context for that. All right, let me go ahead and finish these up, and then I'll go ahead and get into some of your guys' questions or any other math questions that you guys have. All right, so the next one is just asking for simplifying. Obviously, guys, we can see that this function we are going to. Why is it not? Oh, that's not what I wanted to do. I wanted to do fit to width. There we go. All right, so on this one, basically we can see that we have these two expressions that have a common factor of sine squared. So we can factor out a sine squared. So by factoring out a sine squared, what we're left with is 1 plus cotangent squared of x equals. Now again, remember cotangent squared of x is a Pythagorean identity for cosecant squared. And then sine squared of x, I don't know why my handwriting looks so bad, but sine squared of x times cosecant squared, those are reciprocals of one another. So that answer is going to be 1. The next example might be easier just to understand this in terms of sines and cosines. So I'll rewrite this as 1 over cosine over 1 over sine of x. And then you could multiply by the reciprocal. And when you do that, you would get a sine of x over cosine of x, which is tangent of x. Next one here, again, we see the cosine squared over sine squared, which is going to be cotangent squared of x. Cosecant of theta times sine of theta, again, are reciprocals. So again, we have this cotangent squared of x plus 1 is going to be another cosecant squared of x. This next example, good question. It's a good question. So what I decided to do, there's a couple different ways you could do this. The way that I decided to do it was, I know that sine squared and cosine squared are related to each other using the Pythagorean identities. So what I decided to do was I'm just going to rewrite sine squared as cosine squared of x, because the only time I liked solving for sines and cosines when I had two of them was when I had the zero product property. And I don't really like, I can't really create this, obviously you could factor a difference of two squares, but then you still have to solve, how is that going to help you? So what I found to be the easiest here was by rewriting this expression and only in terms of sines and cosines, I could rewrite this as 1 minus 2 cosine squared of x equals 0. So let's say that's going to be a -1, so that's cosine squared of x is going to equal a 1 over 2, and then obviously we've been through this again. This is the same really question that we already did. Cosine squared of x equals plus or minus the square root of 2 over 2. And therefore, if you look at the unit circle, all those answers would be D. Last example is 5 cosecant of theta minus 2. So again, let's just isolate here. So we have 5 cosecant of theta equals 5. divided by 5, divided by 5, cosecant of theta equals 1. And remember that like cosecant is 1 over y, right? Based on the unit circle. Or you can just think of it as its reciprocal identity. Sine of theta then is also equal to 1. So we think of the unit circle when is sine equal to 1, and that's going to equal pi halves. So there you go, ladies and gentlemen. That is the whole quiz answered for you. And that's it. So now let's kind of get into some questions here for just a little bit with you guys. And now we got some basic, how do I simplify trigonometric identity? So I will get to that in a second. I just want to see. All right, so Iron Spire said, what is your opinion on AP Calculus? I mean, I've taught AP Calculus. I like AP Calculus. And I like calculus. I do wish we would, I don't think there needs to be such an emphasis on everybody taking AP. I think our society would be much better off if we had more people just exposed to calculus, but not under this this rigorous AP curriculum, which is good. It's not good for the majority, for everybody. And I think what we've kind of done is built this idea that if you're not taking AP classes, you're not doing AP calculus, then it's not worth it. And I think that's a very dangerous kind of road to be heading down, which we've already been heading down for a while. I see a lot of students that are stressed out. They're not prepared for these upper level classes, but they're only taking them because they feel like that's the only way they're going to get into a college and get a job. And then we're starting to see some of these, crumbling where, because people don't really, colleges aren't, colleges and employers are not needing as much, and people are getting so much in debt for going to schools. And so it's kind of interesting. I do like AP Calculus. I just, I don't think we need to push so many people into it at such a young age. So that's just kind of a quick opinion for me on there. There's a little bit more I'd like to say, but I'll kind of keep it short. All right. So I think that was everything else I wanted to. You're very welcome for the stream, Hash Brown. You're the best. Let me know what kind of factoring, graphing. I'll be happy to do one. Can you tell me what your next stream is? I'm going to have some questions for factoring. Sure, that's a problem. And actually, that's a good thing. I'll let you guys know. I think I am going to plan on going live probably on Monday. Yeah, so I'll be going live on Monday. And actually, if you guys want to, what I'll do is I'll try to make for those of you guys that actually, I think the easiest way to be able to do them, what I'll do is I'll put for those of you guys are not, well, actually, let me see if I can do this actually. What I'll do is I'll put I'm going to put a link to my Facebook page, and I want to try to test this out. So if you guys aren't interested, or if you have questions, or you want me to talk about anything, I will plan on covering these, covering these questions. So what I'll do is I will put a kind of reminder on the Facebook Free Math Videos on my Facebook page. And then if you guys have any kind of questions, you guys can just comment below. And then before I go live, what I'll do is I will make sure I address those questions. So I'm posting this link in the chat. It looks like a very, very big link, like bigger than any link that I have pasted. Yeah, it's like huge. Why is it like that? What the heck? Okay. Let's try that again. Oh my God. You gotta be kidding me. Yeah, why can't I just go to Facebook, and then I think it's just facebook.com free math videos, I believe. That should take you there. Let me just double check here real quick. If you just go, there you go. So if you would like to answer, to write down any questions or have me address anything before my stream or like obviously during my stream, then feel free just to go to my page. And then when I go ahead and post for my next stream, which I'm planning on doing tomorrow, because I got to cover homework on sum and difference of two functions. So I'll plan on doing that tomorrow. And then actually, I think, I'm going to go tomorrow and then probably on Tuesday as well. So we're going to do live quite a bit. And then we're going to have a quiz, and then I'm going to go live again. So, yeah, so there's going to be a lot of live streams this week. So, but I'll definitely try to communicate to you guys a little bit better. That was one thing, that I wrote down this year that I wanted to do a little better, was just kind of get that communication for you guys, let you know when I'm going live. It's just very tough. Obviously, working full-time with school, and then also working, left school, and then obviously coming home, and then, having two kids under the age of 2, and then obviously having more work to be done from there. So I was going to go and do a problem from HNKL, but as far as graphing it goes, I am not really sure. I mean, I would just use the I would just go ahead and use a graphing calculator as far as graphing those. Or basically, how do I simplify it into a single trigonometric identity that I can graph? Well, all right. So now I'll go and see if we can do something with that. So 2 sine of x, because I do see you can do some factoring, maybe. Sine cubed of x, cosine of x. So let's see. I mean, if I factor, you can factor out a cosine, a sine, and a cosine. So if you factor out a sine of x and a cosine of x, you're going to be left with a 2 cosine squared minus 2. Oh, I guess I could have factored out a 2, right? So let's factor out a 2. So therefore, we're left with a cosine squared minus sine squared. Now, that's not really helping us with anything else either. That can't be simplified. If it was cosine squared plus sine squared, then obviously we know that'd go to 1. But that's just going to equal, a 1 minus 2 sine squared, or a 1 minus cosine, or 1 minus 2 cosine squared. So I'm not really sure what else I would do for you to simplify that. Or as far as graphing, we don't really cover graphing with sines and cosines. We just do the single trigonometric functions in my class. So it's not something I remember off the top of my head what you would want to do. Otherwise, just using graphing technology. And attack clips, that is not very nice. So I guess I'll hide your message. Attack clips, yes, this can help you very much in life. Of course, verifying identities, they happen all the time in life, in real life. So, all right. Or basically, Evan Gessner website. What about my website? The website's up. It's now live. Yes. Free Math Videos has been changed. I haven't worked on the back end yet though. So obviously there's still a lot of things I have to personally do to the website, some back end stuff, but the website is completely changed around for you guys, but I think it's a little bit easier to navigate from the user end, and so therefore you guys can find videos a little bit easier and kind of find what you're looking for. And then obviously this is really just the bare bones of my website, and then what I'm looking into doing now is I'm going to be adding a lot more stuff coming up there. So, I says, man, I bought my first 2 exams. Sorry to hear about that. Damn near flawless to the A. I'm new to trig, and the material hit me like a truck. Will you go over polar coordinates? I will be going over polar coordinates. We don't really go deep into my class. We really just kind of talk about how to convert, kind of explaining polar coordinates and how to convert between polar and rectangular coordinates, as well as between polar and rectangular equations. But that's about it. I don't get into graphing polar graphs or anything like that. We just don't have time in our curriculum to do that. So we just kind of focus on the kind of the basics of the polar. But we will be getting into it, but it's not going to happen until probably about 3 or 4 weeks from you there. And it's the man himself. Hey, Get a Gamer, how are you? Good to see you back in for another stream. All right. Can I email you your Firebird instructor? Yeah, I said go ahead and check that link. You know, if that doesn't work that we have, I'll make a post tonight, so therefore you can go ahead and follow that. But if that doesn't work, then obviously I just get a lot of emails. So I mean, you can email me, but I just hate for something that you want me to respond to, just to get lost in my email kind of like bin. You know, so I'd like to try this Facebook, so therefore I kind of know before I go live, I can check what people have written and what we need to cover, and then I can help you guys that way rather than trying to remember where messages come all throughout the week when I'm getting multiple emails, you know, throughout the day. All right. I was trying to look at your merchandise and it says I have to download a document and open it, but when I do, there is an abundance of coding. Is that down a moment? Yeah, so for those of you, Eli's referring to my merchandise that I just decided to have a little fun with. For anybody that's interested in merchandise. But I don't know. I mean, I did purchase one shirt for myself to kind of test the product because I wanted to kind of see, you know, how nice the shirts are. And I will say, actually, I was pleasantly surprised. Unfortunately, though, I bought the shirt before I like learned I could change the pricing. So I bought the shirt like at full price. I mean, obviously, I guess like I got the extra money came to me somehow. Actually, I don't know. No, I just bought it for myself. Yeah, I don't know. It was more expensive. I paid more than what I offer the shirts now because then I learned I can actually reduce the price of the shirts basically from my account. So, but I mean, I didn't have a problem doing it, so it could be down. You know, maybe I'll go and check again. I haven't since I kind of launched some of the merchandise. I haven't tried buying one of those shirts, so I'll go and take a look at that and maybe see what it is, and you know, we'll check in during the week, see if that's the case. Yes, I have random live streams, but I will say, guys, I am going to be live quite a bit this week. Let me see. Well, actually, tomorrow's Tuesday, so I won't do the quiz on Tuesday. Or I won't do the quiz this week, but I will have 2 homework live streams that I'll be doing this week. So I will plan on doing them at least. I'll plan on at least doing hopefully one. Oh, yeah, tomorrow's going to be Tuesday. I kind of forgot about that. Yeah, so let's maybe plan on, like, Tuesday. And, yeah, I'm actually going to have to go, like, back-to-back Tuesday and Wednesday this week. So unless something comes up, I'm not going to do it. All right. All right, guys, I think I'm going to have to wrap up the stream. But how do you find the period of a basic sinusoidal graph? Oceanic sites. Well, for sine and cosine, that is going to be 2 pi divided by b. So basically you just find b from the equation of your transformations and then take 2 pi and divide it by b, and that will take you for the how to find the period. So all right, guys, I think we're going to wrap up the stream though now because I still have some quizzes I got to go ahead and grade, but hopefully you guys got some help with trigonometric identities. And then again, follow that Facebook link if you guys would like to go ahead and take a look at the Facebook link if you guys have some questions here for my next live stream, which I'll plan on doing tomorrow. And then, yeah, that'll be it. See you guys later. Cheers. Oh, wait. What?